Thank you very much. Lesedi Katadi, inputs please.
So far, so you explain everything well and understand it.
Thank you very much. His Excellency Mr. Nyakalo Nyokong.
I'm still keeping up, sir.
Thank you very much. Motao CDT.
So is it fine if you can just explain velocity versus time real quick?
Thank you very much. Ratanang Pehlo.
Sir, so far I understand.
Thank you very much. VC.
I'm understanding so far, sir.
Thank you very much. Now, for velocity versus time, Moteo, let's maybe go back to the slide where this tennis ball of ours was moving towards the ball with 20 meters per second. So we're calculating the momentum before, but we are told that it is already moving with 20. So we are not interested in the momentum, but interested in the velocity, which is now 20 meters per second. But we said right as positive and then left as negative. So it bounces off the wall with 15 meters per second. Ne? So we have 15, we have 20. 20 before, 15 after. So what do? We said now positive according to the Cartesian plane. This is now, let me use red. This is now positive, this is now negative. So 20 is positive 20 meters per second. 15 it's negative 15 meters per second. Why? Choice of direction. Then we can be able to say for a certain period of time before it hits the wall, it was moving with 20 meters per second. Hence we have a horizontal line. However, it is going now to collide with the wall for a certain period of time. And during that collision, for it to be able to change the direction, it means velocity must be zero. So in this instance here, v is equals to 0 according now to what? According to the principles of mathematics, to say when you are on the x-axis, everything or a quantity that is on the y-axis, it is actually 0 and vice versa. Then immediately after changing direction, it is no longer traveling with 20 meters per second, but it is traveling some time now with what? With 15 meters per second. That is the reason why now we have such a graph, or a graph looking like this. So just remember, this is now before, and now this is after. But we are only focusing on what? On the velocity of the object. Can we do the same? Yes, we can. By doing what? By saying now we want, that is number 6. At number 6, we want now graph of momentum versus time. Now we are going to draw momentum versus time, not velocity versus time. So for us to draw momentum versus time, it means the same principles must apply. But what are the principles? The principles are saying this is now right, this is now left. Why? Because momentum, ladies and gentlemen, it's now what? A vector quantity. So it being a vector quantity, we can assign direction to it. But we calculated the momentum before. So we'll have the momentum before, but now it's going to collide with an object. Collide with an object, change the direction and then have a different momentum after, something like this. So they look like they are the same. However, this is now momentum versus time in seconds. Why? Because this is now P initial and this is now P final, and this section here, ladies and gentlemen, it's now during the collision. So the only thing that is left is for me now to add the values. I remember something like this one here must be 0,855 and this one 1,14. So it is exactly the same graph, but now we are looking at momentum versus time. So when you are given, ladies and gentlemen, a graph of momentum versus time, just kindly check what is it that you are given. Is it either momentum or is it now velocity versus time? But generally they will work now the same way, ladies and gentlemen. Now this brings me now to number 7. Number 7, we say Newton's second law. Newton's second law expressed in terms of momentum. Khatanam Phehlo, Newton's second law, please.
Sir, I forgot.
Muteo, Newton's second law.
I also forgot, sir.
Lesedi Katadi, Newton's second law.
So Newton's second law says that when an object exerts a force, the force will accelerate in the direction of the force at an acceleration directly proportional to the. I forgot that part.
Thank you very much. Ladies and gentlemen, last year I emphasized to say this topic overlaps, those are critical concepts. You are still going to be assessed on issues of grade 11, especially Newton's laws, stoichiometric calculations, acids and base, all those ones that we emphasized on. So all I'm saying is, when you do your studying now, at the back of your mind always have those topics I referred to. I will write them down for you also, for you to remember. If you still have challenges on those topics, they are going to restrict us to achieve the desired goals, because Newton's will be from March until the end of the year. It will still be there. So if we still have challenges on those, ladies and gentlemen, please come forth. Let's address them as early as now. But however, during towards the the control test, we will be able to revise Newton's laws as well. And the date for the control test, if you have a pen, it's now the 12th of March. 12th March, it is now the date for the control test. I will share the scope. I know the schools don't have the date as yet. They'll probably get it sometime next week, but I already have it from my reliable sources. It is now the 12th of March. So we don't have much time, ladies and gentlemen. Thank you. Now it says here, Newton's second law expressed in terms of momentum. It says the net force the net force exerted on an object, exerted on an object is equal to the rate of change in momentum. Can we write down the formula for this? Yes. The net force exerted on an object is the rate of change. What is the rate? Rate, ladies and gentlemen, is the measure of time. Changing P over changing T. Then this becomes now my equation number 2 for momentum and impulse. This will be very important. Why will it be very important, ladies and gentlemen? It is having Newton's second law inside of it. So we must be able to calculate that F net. Do you see now? Which means now correct free body diagram, number of forces acting on the object, the actual number of forces that are making this object to move. Also consider that object, saying can we be able to calculate the change in momentum and also the change in the given time. Ladies and gentlemen, Newton's laws are very important. They are coming up again. So imagine if you are unable to draw a correct free body diagram. Imagine if you are unable to identify all the forces that are doing work. Please. At number 8, we now introduce a new concept that we call impulse. An impulse, ladies and gentlemen, it's now what? The product of the resultant force acting on an object and the time the resultant force acts on the object, acts on an object. This is a definition, ladies and gentlemen. It's commonly asked. The reason why? Because most learners do not get it right. Let's highlight keywords: product of the resultant force acting on an object and the time. As simple as that. F net, product, multiplied by changing time is equals to changing P. So this basically is the same equation as number 2. So equation number 2 explains Newton's second law in terms of momentum. But the very same equation, once you have F net multiplied by changing T, explains now what? The impulse. So impulse is the product of resultant force acting on an object and at the time the resultant force acts on an object. That is very important, ladies and gentlemen. And the SI unit now is Newton second. Some people use kg meters per second. Why kg meters per second? Because if you check there, you still have now change in momentum. So whatever you calculate Either you write kg meters per second, or you now write a Newton second. We will do examples of this, but in actual essence, this is the example itself. Why? Because I can just maybe tell you the time and say the ball was in contact with the wall for 0,01 seconds. So in actual sense, I have the change in momentum, I have the time, which is now 0,01. Then I can basically do that. Then I can easily say F net multiplied by change in t is equals to change in p. What was my change in momentum? 1,995. F net multiply by 0,01. Take my calculator. F net is equals to 1,995 divided by 0,01. Then it gives me something like 1,995 newtons, but now in the direction which is now left. Okay, F net is equals to 199,5. The direction must be left. Why, ladies and gentlemen? From this vector diagram and change in momentum also being negative, then we will be able to get such an answer. His Excellency, questions please.
None, sir. I'm still good.
Thank you very much. Now at number 9, ladies and gentlemen, is the application of impulse. Where can we apply this principle of impulse? At A, let's say in everyday life. Where can we apply this principle of impulse? Ladies and gentlemen, we can apply this principle sorry, A, in airbags, B, in tennis players or basketball players. C, we can apply this in seat belts. We can apply this now in arrestor beds. We can also apply this in what we call crumble zones. That is where we can apply that. And we need to have an explanation for that. The explanation is as the continuation. To explain principles of impulse, consider the following. You say during the collision, the airbag inflates inflates, and the contact time of the passenger with the airbag is longer or increases. The net force increases. Not true. The net force decreases, comma, for the same change in momentum, full stop, according to F net is equals to changing P over changing T. 4 marks. Very, very, very important. Ladies and gentlemen, I can't explain it further than this. I'm using an airbag as an example, but all other ones work the same way. So what does this airbag do? Remember, the airbag is going to push the driver backwards during a collision. But what it actually does when it inflates, it's that the passenger will now have longer contact time with the airbag. Then the net force of which the passenger was going to hit the steering wheel, which is now very hard surface, decreases for the same change in momentum according to this. So what the airbag does is it increases this contact time. Then F net becomes smaller. Then the passenger becomes less injured. Very, very, very important. Less injured. So if your car does not have an airbag, you become more injured. At the very same time, if you put now the seat belt, during the collision, the seat belts will push the passenger back and now creating a longer time between the passenger and the seat belt. The net force decreases for the same change in momentum according to the equation F net is equals to changing P over changing T, and the passenger will become now less injured. Hence, during these days, if you don't put in your safety belt, you don't put your safety belt, the airbag will not come out. Why? As a trigger for the insurances people, as a trigger to promote now what? Safe driving. So it is designed, ladies and gentlemen, according to this principle here. Very, very, very important, ladies and gentlemen. Very, very, very important. So we will apply that, and when we apply this, please just follow and just read the questions thereof. Now we are at number 10. At number 10, ladies and gentlemen, we're speaking now of conservation of linear momenta. Conservation of linear momentum. Your Excellency, grade 10 conservation of mechanical energy. What does it say? Grade 10.
Isn't it something like the mechanical energy before is the same as the mechanical energy after?
It is not something like that.
Ah,
Yeah, no, not something like that. Lesedi Katadi,
So
mechanical energy, grade 10.
honestly, sir, I don't remember it.
Thank you very much. What it says in grade 10, sorry, conservation of mechanical energy. The total mechanical energy of an isolated system is conserved. You must remember that. You are going to need it somewhere this year. Now, why am I referring to conservation? Everything that has conservation in it, we refer to the total. If you do, you are going to get funny definitions of the sum before and what. But the easiest way of you getting full 2 marks without losing everything is just to say the total linear momentum of an isolated system is conserved. You are going to get something like the sum of the momentum before is equals to the sum of the momentum after. Ladies and gentlemen, as per CAPS document, as per definitions and terms that you are going to get this year of 2024, the total linear momentum, I repeat, the total linear momentum of an isolated system is conserved. Easy, free, standard, 2 marks. Don't complicate the science. Please, 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 please. You are going to get all these other funny things. But I'm requesting that we stick to this one. The total linear momentum of an isolated system is conserved. Because those other ones that you are going to use, they are going to extend it and bring things like in both magnitude and direction, which makes now the science even more complex and more complex. Ladies and gentlemen, please, let's use this one. But what does this thing say in basic simple English? It says total is the sum of momentum before is equals to the sum of momentum after. When we do problems and exercises, you will see I will be sharing hints also as to when and how can you differentiate when to use conservation of linear momentum as well as impulse equation as well as just momentum equation. Please follow up, but for now, basic concepts very, very, very important. Now, where can we apply this? The application. And please keep these notes very, very close to your heart. Why? Because it will be a checklist, it will be an information that assists you and saves you time instead of going through the textbook and everything else. So when we practice, let's check that we are doing something they call explosion. Let's check that we are able to do two objects colliding and moving together after Let's also check that we are able to do two objects colliding and moving separately after the collision. That is where we are going to apply this. Moteo CDT, are you still following?
Yes, sir.
Thank you very much. Now let's move, ladies and gentlemen, to this last section. This last section, we call it types of collisions. We have elastic collision, and then we have inelastic collision. Now, key critical thing, momentum is conserved. Momentum is conserved. So it says I cannot be using momentum to prove whether the collision is elastic or inelastic. I need some extended information for me to do that. Extended information is that both, okay, let's say kinetic energy, the total kinetic energy is conserved. So if I can prove that the energy, especially the kinetic energy before the collision, is equals to the kinetic energy after the collision, then that collision we are going to call it an elastic collision. So we say the sum of EK before is equals to the sum of EK after. If I can prove that this thing is actually true for the calculations that I have, then it means that collision is elastic. However, for inelastic, total kinetic energy is not conserved. Very, very important. That means now the sum of EK before is not equals to the sum of kinetic energy after. So if I can prove that the sum of the kinetic energy before is not equals to the sum of kinetic energy after, then I will be in a position, ladies and gentlemen, to say this collision is actually inelastic collision. But what is the reason for it being inelastic, or the energy before is not equal? Is because energy is lost, and we did say now it is lost in a form of either heat, light, and sound, because you eventually get other now cars that are burning. Ladies and gentlemen, I am proud to say we are done with topic 1 of grade 12 term 1. I repeat, we are done with the topic of term 1 grade 12. All the concepts have been explained. Tomorrow and Friday we will be doing problems. What problems? Problems that will enhance the teaching of these concepts. Your teachers will give you what we call the teaching plan, or the ATP. You will see in that ATP that all these concepts are there. But obviously this is physical science. Concepts explained fully, clean. Key critical thing, when we get a question paper, when we get a question, how best can we apply such principles? So I'm going to pause here, save this file, give you the e-notes, ladies and gentlemen. Please, tomorrow you're not going anywhere, just go through them just to understand what is elastic, what is inelastic, what is momentum, what is impulse, what is critical in terms of the choice of direction. All other things will make sense when we expose ourselves now to what? To different sets of questions. So the way I'm going to choose the questions, I might also be taking what we call high order questions, but it's not to demoralize you, it's to give you a skill, and a critical skill, ladies and gentlemen, that regardless of what the examiners are going to ask, you will be able to perform very well. Ratanang Phehlo, reflections and inputs of the first class of 2024.